Yes, sir.
Yes, sir.
ओके वेल सो हम इस चैप्टर को थोड़ा सा रिव्यू कर रहे हैं, थोड़ा सा समराइज कर रहे हैं, क्योंकि चैप्टर हम खत्म कर चुके हैं ऑलरेडी. वी हैव फिनिश्ड द चैप्टर. ठीक है, सो वी आर जस्ट गोइंग टू डू द रिव्यू ऑफ द चैप्टर इन अ लिटिल बिट टाइम so that we can have an idea about the material properties, atomic structure, and many more things. The first topic in the structure was atomic structure, and we've gone through a lot of things. First, we studied about the models, that what basically a model is. So basically, the model is used to predict something because we cannot see inside anything. So we have to predict about that. So scientists use that model to describe an object or a system. And a scientific model, you know that it is very a simple thing as compared to its original object. Like for example, the original object may be more complex than what the model explains it. So model is doing what? It is simplifying the things for you. Okay, it is predicting for you something so that you can go and study that, and you can study that easily. So that what the model of atom can represent to you, or model of anything can represent to you. Okay, let's see now. The first model was explained, which was given, was solid atoms. Okay, and it was done in earlier 1900, when scientists imagined that atoms are solid spheres. But in this model, they normally say that atoms are basically made up of solid spheres, and the particle model was basically, this was the particle model. So it explained that the solids are going to be very much close to one another, the atoms will be very much close to one another. In liquid, the particles will be a little bit farther from one another, and in gases, the particle will be more farther from one another. So this model basically explains the behavior of solid, liquid, and gases. Okay, and it also explains that how the particle diffuses. Like for example, gas diffuse faster, liquid diffuse after the gases, and solid does not diffuse. So this is how it explains the thing. It also explains the density. Okay, the density of solid is very much higher than the liquid and the gases. But this model was not able to explain everything with which we needed, which the chemist needed. So because it cannot explain how the atom join together, it cannot explain how chemical reactions takes place. So scientists have to do what? They have to make new models, okay, to predict that how the atom behaves. So in the new model, what they have explained initially, they have explained about this is the last model which we are discussing today. 1932 is basically the last model. Okay, before that, we know that a lot of effort were made, and that effort was made by J.J. Thomson, that was made by Nagaoka, that was made by Rutherford, and many more scientists were there who made a lot of effort to make this model clear. Okay, so this was 1932 model, which is normally known as the modern atomic model. And this model explains us that an atom is made up of subatomic particles, and that subatomic particles are protons, neutrons, and electrons. This model also explains that how chemical reactions takes place. Okay, and this model also explains us that there is a nucleus present in the center of the atom, and all the mass of the atom is present in its nucleus. It also predicts that electron revolves around the nucleus. Okay, so this is a new model, and this model, again, I'm telling you that this model was made after a lot of efforts. A lot of scientists made a lot of predictions, a lot of experiments was carried on, and after those experiments, those predictions, this new model of atom was possible. Okay, it was only possible after those many experiments, those many scientists who have worked together, and after this model was possible. So this was the model of the atom, the modern model of the atom. It says that proton and neutron are present in the center, electrons are revolving around the nucleus, that is around the protons and neutrons. So electron, this says, are negative particles, proton are positive particles, and neutrons are neutral particles. This was a charge by mass ratio. Proton is relative mass 1. Okay, its charge is positive 1. Neutron has relative mass 1, its charge is negative. And electron is much lighter particle, its relative mass is 1 upon 1840 as compared to neutron and proton, and its charge is -1. So the masses are basically, you can say, very tiny, and negligible masses are present in these particles. The most lightest particle is electron. Okay, सबसे जो light particle है वो कौन सा, वो electron यहाँ पर present होता है इनके अंदर. So this was all about the new model which was explained. Okay, and they also told us that basically the nucleus is that much smaller. Like for example, there is a football ground, and the nucleus, the football ground is the example of the atom, and the nucleus is basically is like a football present in that ground, or maybe even smaller than that football as well. So you can imagine that how small the nucleus is and how bigger the atom is. The atom is much bigger than its central particle, than its nucleus. Okay, and this means that the nucleus is very highly dense particle. Dense particle means that the mass is present in the center. Okay, the positive and the neutral particles are present in the center. The atomic mass is present in the center, that is represented by the protons and neutrons. This is what this model was saying. Okay, now we also discussed that atom has no charge on it. Electrically, atom is neutral. And why electrically atom is neutral? Because the number of proton and number of electron are same. We know proton are positive particles and electrons are negative particles. When two same numbers having opposite charges on it, like positive and negative charges on it, so what will they do? They will cancel each other. When they cancel each other, so overall the atom become neutral, because the neutral particle, the neutron, has no particles on it. So okay, or there is no charge on the neutron. The only charge present is on proton and electron. So on proton and electron, what happens? The charges are cancelled. Okay, they cancel one another. When the charges are cancelled, so the atom become electrically neutral. This question can be asked from you in the exam, that why atom is electrically neutral. So आपने बहुत simple सा जवाब देना है. Atom is electrically neutral because they have the same number of protons and electrons. So when the number of protons and electrons are same and the charges on them are opposite, they will cancel out each other. When they cancels out each other, the charge become neutral. There will be no charge on the atom. So atom becomes electrically neutral. Okay. This is how we can explain it. That for example, we are having two electrons and we are having two protons in the center. So the 2 plus charge and the 2 minus charge are going to cancel one another. And what will left? Neutron will be left. Neutron has no charge. So atom become electrically neutral. Okay, let's see. The second topic, that was finding electrons, was again a very hard work done by many scientists, that how to find out the electrons. The major work about this was done by J.J. Thomson, but initially this was done by many scientists. Okay, so that was in the 1800s. Now you can see that the model which we explained previously was 1932 model. So it means that there's a lot of gap between the new model and the finding when it started. The finding started very much earlier. So in the late 1800s, scientists investigated about many gases, and after that, they perform an experiment in a closed tube, in a closed seal, you can say discharge tube, and they supply that with an electric current. So when huge electrical supply and voltages were supplied, they amazingly saw that the gases conducted electricity. And in 1869, there was a scientist, John Hathorp. He noticed that a green glow was presented on the screen. As I saw you people, I show you people on the in the video as well. You have seen in the video that when it was striking the screen, it was glowing green. Okay, so he said that the glow is caused by rays from the negative electrode, from the negative side. Okay, so when these rays are emitting from the negative side, they are going to strike the positive side, and on the positive side they are glowing over there. So that rays were known as cathode rays. Okay, the scientists named these rays as cathode rays. So cathode rays were negative particles which was emitting from the positive from the negative plate, and it was going and striking the positive plate. Okay, so this was basically like like for example, this was the experiment. जिनका माइक ऑन है काइंडली टर्न ऑफ कर ले. माइक कितनी बार बोलना पड़ता है. ठीक है. So this was the discharge tube experiment, and you can see this discharge tube experiment. There is a fluorescent screen present at this side, this fluorescent screen. Okay, there is a high voltage source present over here, and this is the negative electrode and this is the positive electrode. So when they passes the current, जैसे current pass किया इन्होंने, from here rays were emitting, and these rays were passing these positive electrodes and was striking this fluorescent screen over here. So it was glowing green. You can see here a green glow present over here. So they said that these rays are cathode rays that travel right from the negative electrode towards the positive electrode, and they are striking this fluorescent screen. So it means that they are negative rays traveling from negative to positive. Okay, because the positive is going to attract the negative. That's how they're traveling. This is the experiment they have performed. On the basis of this experiment, J.J. Thomson worked. Okay, Joseph John Thomson work was on the cathode rays, and he suggested that cathode rays may be electrically charged. This was just a suggestion, and he collected for some evidence for his to test his idea that either these particles are electrically charged or not. So what he did, he placed the positive and negative charges of the metal pieces. They have placed one with the positive charge, other with the negative charge, and then they started to pass on the rays from that. So as he started to pass on the rays from those positive and negative particles, what happened? The rays were normally bending towards the positive plate. So he said that these rays are emitting from the negative electrode and they are bending toward the positive side. It means that they are negative rays. Okay, so the negative rays were basically introduced. The cathode rays were said that they are negative rays. This was done by J.J. Thomson, and J.J. Thomson collected more evidence, and he concluded that cathode rays are made up of particles. And at last, they said that basically an atom is also made up of charged particle. And what is the charged particle? That charged particle is negatively charged, and that is known as electron. So in 1897, the first atomic particle, that is the electron, was discovered, and that was discovered by J.J. Thomson. इसके बाद जितना भी काम हमारे पास होता है वो इसी इलेक्ट्रॉन के डिस्कवरी पर ही होता है, और हम इलेक्ट्रॉन को ही ज्यादा डिस्कस कर रहे होते हैं कि इलेक्ट्रॉन्स जो है, जो नेगेटिव पार्टिकल्स है, वो पॉजिटिव पार्टिकल्स के अंदर प्रेजेंट होते हैं. So this is how it was done initially by J.J. Thomson. Okay, then J.J. Thomson gave a new model of atom. When he thought about the electrons, he knew that it is made up of material. He also knew that the materials are made up of basically atoms. Okay, so atoms combine together and they make materials. So what he concluded, he suggested a new model, and that new model is known as J.J. Thomson plum pudding model. And what he said in that plum pudding model, very simple. According to this model, the negatively charged electrons are placed throughout a positively charged sphere. Okay, the negatively charged electrons are placed throughout the positively charged sphere like plums in a pudding, like this one. Okay, this is basically, this one is a plum in a pudding. So this is a positive sphere according to J.J. Thomson. This is a positive sphere. This is a positive sphere, and the negative electrons are scattered like this. They are placed like this. They are placed like this. Okay, this was the first, you can say, electronic model which was presented, and this model depends upon the discovery of the electrons. So when the electrons were discovered, this model was made possible. Okay, and after this, J.J. Thomson model, when he gave this model, he gave his idea, a lot of work has been started, and the next model which was presented was by Negaoka's Saturn model. So Negaoka was basically a Japanese scientist, and he studied J.J. Thomson model, and he collected many evidences by other scientists as well. And then he said that the J.J. Thomson model cannot be correct. Okay, it is not possible for a negative charge particle to be spread in the positivity sphere, because when the positive and negative particles are placed with one another, what is going to happen? The negative particles are going to be attracted by the positive particle, and the atom can be destroyed. So what he said, what he suggested that an atom consists of a positively charged center. Okay, the center is positively charged, and the electrons are basically going to orbit in the ring. Like, for example, the planets. Okay, the planets are revolving around the sun in a ring, or you can say the planet Saturn. So because of this, his model was known as Nagaoka's Saturn model. Nagaoka's Saturn model, this was the Nagaoka's Saturn model. Now you can see he said that the center of the atom is positive and the electron revolve around it. Okay, the difference between Nagaoka model and plum pudding model is because the plum pudding model says that the positive sphere, which we can see over here, the positive sphere, the electrons are scattered in this positive sphere. And what Japanese scientist Nagaoka said that the center is positive and the negative particle electron revolve around the nucleus. Okay, but he also says that the atom is big, like a Saturn, and the orbit is basically a smaller one where the electron revolves. So this model again gives you a little bit idea about the atom, but definitely this is also a different model. So some prediction was made. Okay, something was made, and after that it was made possible that something regarding the atom could be discussed. Okay, so till here we have repeated the thing. I hope कि थोड़ा बहुत जिन स्टूडेंट्स ने जो है मिस किया था उनको दोबारा से थोड़ा सा जो चीज समझ आई होगी उनके लिए रिपीट हुआ होगा, और जिन स्टूडेंट्स ने पहले से अच्छी तरीके से पढ़ा था उनके दिमाग में जहन में जो है वो थोड़ा सा समरी जो है वो चैप्टर की वो रिवाइंड हो गई होगी। आई होप सो कि ऐसा